Okay, so we are going to start with some vocabulary. We are now starting our exponentials unit. So, some basic vocabulary that you have to know. Okay, so the base of an exponential expression is going to either be the number or the variable, because it can be a variable, that is being multiplied. Okay, and the exponent is also going to either be a number or a variable that shows how many times a base is multiplied. Okay, and so you can have a combination of all of these, a number raised to a variable raised to a number. So some quick examples. Okay, on the first one, your base is 6 and your exponent is 3. So the base of 6 is being multiplied 3 times. So that's basically 6 times 6 times 6, or 216. Okay, on the second example, your base is 2 and x, the variable, is your exponent. And when we get into graphing these, that exponent could be any number, and it would tell you how many times the base is being multiplied. So it will change because you have a variable for the exponent. On the third example, x is your base and your exponent is 5. Okay, so that means x times x times x times x times x, 5 times that you're going to multiply x. And that's not the same thing as 5x, because that would be x plus, 5 times. This is actually being multiplied 5 times, so your exponent is going to be 5. Okay, so we're going to review exponent rules. Some of these you should already know and should have already have worked with, and then we're going to kind of put them all together. Okay, so there are 5 or 6 basic rules for exponents, and they're done in a certain order when we start actually putting it all together. Okay, so the first rule is the addition rule. Okay, when you multiply like bases. Now, that's the big thing, is that your bases have to be the same. This is a lot like square roots, where you could not add or subtract square roots unless the actual number inside the square root was the same. Okay, so very, very similar rule where you have to have like bases. Okay, so when you multiply like bases, you add the exponents. Now, big thing on this, you might want to note, you don't change the base. Okay, the base does not change when we are working with this. So my base is still going to be 6, and I'm going to add 2 plus 3 plus -1. And yes, you can have negative exponents. So 2 plus 3 plus -1 is 4. So this is 6 to the 4th power. Okay. Second example, the base is 3. Okay. So we are going to keep the 3 and we're going to add our exponents. So that's 2x plus x plus 4. Now, this looks a lot like a polynomial that we would have done way back at the beginning of the year. So we're going to add, we're going to combine our like terms, right? And we're just going to write it as best we can as far as simplified. So that's still going to be a 3 for the base. 2x plus 1x is 3x. And then we just add the 4. And that's what it looks like when you're done. And that's as simplified as it's going to get. All right, so let's try one with an actual exponent for our variable for the base. Okay, so my base, they're all x's. So this is still just going to be x. And again, I'm just going to add all 3 of my exponents. So 2 plus 3y plus 5 plus y. And again, go through and combine your like terms. So I'm going to combine 3y and 1y, and that's 4y. And then 5 and 2, and that's going to be 7. Okay, so that is the addition rule. And again, the biggest thing is making sure all of your bases are the same. Okay, so now we have the subtraction rule. Okay, same thing. Your bases have to be the same, must be like bases. Okay, so the way this works, if you see something that is being divided, and remember, fractions mean division. When you see something that's being divided, like bases, you're going to subtract your exponents, okay? And it is always numerator minus denominator, top minus bottom. Always, always, always. We're going to talk about negative exponents or what we do with those later. So if you get a negative for right now, just take a look. We're going to do the numerator minus the denominator. Okay, so same bases. Base is 6. That's going to be 5 minus 2. So that's just 6 to the third power. Okay, so now my base is x, and that is 7 minus negative 3. Okay, numerator minus denominator, 7 minus negative 3. Be careful with your double negatives. That is going to change. So that's going to be x to the 10th power. Okay, check the base. My bases are 2s. Notice that my bases do not cancel. This 6 over 6 did not become 1 because it's not. It's the bases are the same, so we're just looking at the exponents. Okay, so here my bases are 2. So again, numerator minus denominator, negative 3 minus negative 5. And remember, you've got your double negative, so that's going to become addition. If you get stuck, grab a calculator. That's what it's for. This is going to be 2 to the second power. Okay, so that is your subtraction rule. All right, now we've got the multiplication rule. Now, this is kind of a funny one because we don't have to worry about like bases for this. What we're seeing is one base, basically with two exponents. You have one exponent raised to another exponent. Okay, so you see one base with two exponents, and you're going to see parentheses with this, right? That's the only way to show that you have one exponent raised to another exponent. Okay, so when you see those parentheses, that's telling you to multiply your exponents. All right, if you think about it, when we do PEMDAS, we work from the outside in, right? Or you could, do what's in the parentheses first, which is 4 to the third, and then you're taking and raising that to the fifth power. And remember, exponents mean that you're multiplying repeatedly, right? So what I have in my parentheses is this, but I have 5 of them. Ooh, that's a lot of writing. Right? So I have 3 4s in each parentheses, and I have 5 of those parentheses. That's what that rule means. So if you count them all up, since they're all being multiplied, I have 4 to the 15th power, which is basically 3 times 5. Okay. Another part of the multiplication rule is it's a lot like distributing because, again, I have to make sure I'm putting all of these things to the fourth power, right? Again, if I write it out, what I have in the parentheses is 2 x's and a y, and that tells me that I have 4 of those. Okay, and again, it's all being multiplied, so I can add it all up. That's going to be 8 x's and 4 y's. Okay, if you look at it like multiplication, I'm doing 2 times 4 for the x's, and that invisible 1 that's always there, if there's no other exponent written, times 4. Okay, and this works when you have whole numbers as well, because again, that invisible exponent is still there. That is a 5 to the first power. Okay, so if I distribute my 3 to both pieces, what I have is 5 to the third, x to the sixth. And if you want to simplify the 5 to the third, it's not always required. That would be 125 x to the sixth. So we need to make sure we are hitting that exponent on everything that is in the parentheses. And again, if you have to remind yourself, rewrite it. I've got 5 times x 3 times. So we have to multiply the whole number as well. And that's usually what people forget. So I have 5 times 5 times 5, 5 to the third, and a total of 6 x's. Okay, so now let's talk about negative exponents. Okay, we're not allowed to leave exponents as a negative number. It's sort of like getting an equation where you solve the equation and you have like negative y equals 4. You're not allowed to leave that negative there. It's not technically done. You would go through and divide both sides by -1. So we're not allowed to leave exponents as a negative. So we take care of that. We want to rewrite them as a positive number. So what happens is that we need to reciprocate them. Okay, reciprocate meaning that you're basically flipping it over as if it was a fraction, right? And think about it. Right now, I can write anything as a fraction by putting it over a 1. So if I have a negative exponent like this, the x is going to go to the bottom of the fraction. It's going to be flipped over, and it's now going to be a positive 4. Okay, so when you reciprocate it, it automatically goes from negative to positive. Okay, so if it's on the top of that fraction, it's going to become 1 over x to the 4th. Right, so now my 4 is a positive, and the x went from the top of the fraction to the bottom. Okay, so same rule applies as far as reciprocating. If it was on the top of the fraction, it goes to the bottom. Well, now this y that has a negative exponent is on the bottom of the fraction, so it needs to go to the top of the fraction. This x already has a positive exponent, so we're not going to mess with it. It's already good. So this expression becomes x squared. X is already positive, and then the y has to move up to the top of the fraction. So you could put this all over a 1 if you wanted to show those are both at the top of a fraction. Now, do you have to put the 1 there? No. If you don't see it as a fraction, it's automatically the numerator. Right? So that's what that's going to become. The y moves to the top of the fraction, and the 3 becomes positive. All right, so let's do a little combining with some of our other rules. Okay, so this is an addition rule, right? I have like bases that are being multiplied, so I'm going to add them. So 4 plus -7 is -3. Okay, and I cannot leave that there at the top of the fraction right now, right? It is at the top. I could put it over a 1. So I have to get rid of my negative exponent by flipping the base over. So that's going to be 1 over 2 raised to the 3rd power. So you're literally flipping your base over completely, whatever it might be. All right, so let's again try this with one of our other rules. We have a subtraction rule. Okay, so I've got like bases that are being divided, so I'm going to subtract my exponents. So -2 minus 5, because we always do numerator minus denominator, always, always. So go ahead and subtract. -2 minus 5 is -7. Okay, and again, I'm not allowed to have a negative exponent, so I'm going to reciprocate my base. The reciprocal of 3 is 1/3, and my exponent becomes positive. And by the way, you might also see this written as 1 over 3 to the 7th power, which is also the same problem because you're flipping the base over and the exponent becomes positive. And it is the actual same answer. If you put both of these in the calculator, you will get the same answer. Okay, and that only works, by the way, if your numerator is a 1. All right, so next rule. Exponent of 0. This is a pretty interesting rule, and if this didn't work, then we would not be able to have base 10. Base 10 like when you do scientific notation, or base 10 when you're like doing kilometers and meters and all that, when you're doing the metric form. Okay, so there's a reason this works. The exponent of 0. So anything raised to the 0 power is 1. okay? Period. That's just the way that works. So this entire parentheses is being raised to the 0 power. So this entire thing becomes 1, right? Because if we were to actually distribute the 0, this would be 2 to the 0 times x to the 0. Each individual piece would be 1, and 1 times 1 is still 1. So if you have a parentheses with a 0, the entire parentheses becomes 1. Okay, works the same way here. If I am working this as an addition problem, I have like bases, it's going to be 3 plus 4 plus 0. So the 0 doesn't count for anything when I'm adding it. So that's just going to be x to the 7th. And it works if you rewrite this x to the 0 as 1. That's still going to be x to the 7th times 1. Okay, same deal here. I could distribute that 0, and 2 times 0 would be 0, and 3 times 0 would also be 0. Or I can realize that the entire parentheses is being raised to the 0 power, so that entire parentheses becomes 1. Okay, so let's see about putting it all together when we have all these different rules in the same type of problem. Okay, there is normally an order that you do these in as far as simplifying them. We normally do the multiplication rule first, okay? Then we take care of the addition, then the subtraction, and then the negatives. That is normally the order that we simplify things in. And if you have any zeros in there, you obviously want to do those first as well because it'll cancel out anything that it has, right? Anything raised to the 0 power being 1. So let's go ahead and take a look. So our multiplication rule says if we have parentheses, right, with that extra exponent, it means all of these pieces in the parentheses are being raised to the 4th power. So let's do our multiplication rule first. And remember, we have to multiply everything, every exponent in here by 4, including that invisible 1 on the bottom. So this is going to be x to the 8th and y to the 12th. And on the bottom, we're going to have x to the 4th and y to the 16th. Okay, so we've taken care of our multiplication rule. Do we have any addition rule to take care of? We don't have any like bases that are being multiplied, so we don't have to worry about our addition rule. So now we have our subtraction rule. And again, numerator minus denominator. We're going to go ahead and subtract our exponents for our like bases. So that's going to be x to the 4th because 8 minus 4. And then this is going to be y to the negative 4 because 12 minus 16. Now take care of your negative rule. Okay, so the x does not need to change. It's positive. It's all good. Remember, this is over a 1. I need to reciprocate my y, right? Just the y because it's the one that's got the negative exponent. So this is going to become x to the 4th over y to the 4th. And yes, you could write it as x to the 4th times 1 over y to the 4th, which is the same thing. But remember, we want our answer as simple as possible. And simplest form in this case would be to write it as one fraction, not two separate pieces that are being multiplied. Okay, so let's try another one. And again, multiply, add, subtract, negative. So multiply, add, subtract, negative. All right, so multiplication rule. Again, I have parentheses with an extra exponent, so I know I'm going to do my multiplication rule. All right, so that's going to be x to the 3rd, y to the 6th for the first one, right? Because there's that invisible 1. And then the second one is going to be x to the 12th, y to the 4th. And remember, these are all being multiplied, right? If you have two parentheses next to each other, that automatically implies multiplication. And if you have two variables next to each other with nothing in between, that also automatically means multiplication. Okay, so now I've done my multiplication rule. So now let's do our addition rule. Do I have like bases? Yes, I do. I have two x's and two y's. Okay, so I'm going to add the exponents for my x's. That's going to be 15. And add the exponents for my y's. That's going to be 10. I don't have any subtraction or negative, so I'm good to go. All right, so let's see. All right, so again, multiplication, addition, subtraction, negatives. All right, so multiplication rule first. I have to multiply every exponent in my first parentheses by -2. So -4, -6, -6, -4. Okay, so that one's done. And then I'm going to distribute a 3 to all of them in my second parentheses, including the ones on the bottom. So that's a to the 9th, b to the 12th, right, over a to the 3rd, b to the 3rd. So I've multiplied every single exponent in my parentheses by that double exponent that we have. So multiplication rule done. All right, addition rule. So we're going to add. And remember that when you multiply fractions, you multiply top times top and bottom times bottom, right? So this works the same way. So I have a like base here with the -4 and the 9. So that's 5 since I have to add those together. And then with the -6 and the 12 for the b, that's going to be b to the 6th. So I've multiplied my top one together. Now I'm going to multiply my bottom one. So I've got -6 and 3. That's -3. And then -4 and 3 that's supposed to be a b. I'm apparently having a moment because that would not go together otherwise. I apologize for that. That would be b to the -1. It is supposed to be b. Otherwise, no matching, it wouldn't help. Okay, so now we've taken care of the addition rule with a slight mistake on my part. Sorry about that again. Now I'm going to take care of my subtraction rule. And again, numerator minus denominator. So that is a to the 5 minus -3 and b to the 6 minus -1. So that's a to the 8th, b to the 7th. And now, because I've done all of those other rules in a row, I don't have any negatives that I have to take care of. Okay, that's it. See you next time.